Hello and welcome to my lab. You'll find the mess for several projects that are on hold waiting for materials that I haven't ordered yet for various reasons. However, I have acquired the gearboxes for the whiteboard machine, so we can work on that. And really the work that we have to do on that is kind of simple, at least on the face of it. We have to take what was simply a motor, let's see, one of these sides, with the coupler going directly to the shaft that drives the belts, and then replace that with the gearbox right in line, and then the coupler will go there. The only issue, or actually there's two of them, is that the bore on the sun gear that is the input to the gearbox over here is actually 8 millimeters, and the shaft coming out of the motor is 3/8 of an inch. So I'm going to have to actually widen this before we can proceed, which is a little bit of a pain because this is hardened, but we'll get to that. And then, of course, the output of the gearbox here is also quite a bit larger. So luckily, I think we have enough material here to bore this out so that it'll fit on here and it'll be a drop-in replacement. I also had to shorten the shaft, but I did that off camera because it was kind of boring. Once we get all the hardware mounted on this thing, then we'll just go through and completely retune the servos, get them all ready, and see if that fixes the problem. So let's go to the mill and fix these things up. All right, so this is the hardened sun gear that I was talking about earlier. You can't see most of it because there's not much for me to grab on, so I've got to have it down there. But the bore of it is facing upwards. So I'm going to find the center of that bore using this edge finder here. These are really fun to use. You can Google edge finder if you want to see how they work. But once I get the location of that bore, I'm going to take a 3/8 end mill and plunge cut down into it, which is going to be a little tedious. I'm going to just turn the RPM all the way up and just take slow methodical cuts till I can get all the way down, and that's basically all I can do here. But I have already done one off camera and it worked just fine, so we can just get started on that. All right, now that the sun gear is the right diameter here, we can move on. Now the coupler here, because it's got slots cut in it so that you can clamp on the shaft, I have to clamp on something, otherwise the dimensions are going to be all messed up. So I just used the feeler gauges here, kind of shoved that in that slot and clamped down on it. And then do the same V-block technique with that, and same feeler gauge, I'll grab the center, and instead of a plunge cut with an end mill. This time I will be using a boring bar. So let's get into it. All right, that works. It's on there, good and tight. And also this fits nicely as well. I had to grind the shaft down a little bit to make everything fit, so I literally just did that on the bench grinder there. So not the most elegant way of doing it, but it works. So let's just assemble it. Okay, now it's later, actually much later. We've been doing quite a few different things, but the gearboxes are mechanically working. We got the motors retuned because they actually sit there and shake and vibrate around to figure out the mechanical system. So that's just a dialog box in the motor setup, and you just tell it to go, and then it sits there vibrating for up to half an hour. So I went ahead and spared you that, but now we're essentially in a place where we are ready to just run some big G-code program and see if it can just get through the whole thing. So another reason why it's much later is that we have an extra program to do the G-code generation to draw text, because I don't really like the process of opening up some CAD program and having it generate G-code to do the outline of text. It looks a lot better when you actually draw the center line of text, and so just because there's not really anything out there to generate the G-code the way we want, we just went ahead and wrote a little program to take text input and turn it into G-code for the whiteboard. So that should be generally pretty useful in the future, and we'll go ahead and put that on the GitHub, so you can, should be a link in the description, and you should be able to look at that G-code generator if you are interested in that. It's pretty simple, so just, you know, keep that in mind. But with that, I think we can go ahead and just start the test. It's going to run a bunch of text here, and then that same picture of the block here from my CAD. So testing both just drawing pictures and also the text. So here we go. Unfortunately, due to straight cut gears, the whole thing's going to be a lot louder now. We were also able to increase the accelerations a bit, and I think I might continue to try to up the accelerations, because I think we can, now that we have as much torque as we have, I think we can continue to get some speed out of it. But I'll just keep playing along with how much I can get before it starts to make mistakes. So I'll just leave you with some shots of this. I'll see you next time.